Last time we learned that earthquakes are caused when you have a fault that's stuck, that there's friction keeping it locked together, but plates are trying to move, and so stress builds up and builds up until finally it gets so much that friction isn't enough to hold back the fault, and it suddenly releases all of its energy in what we call an earthquake. And of course, we said that happened over and over and over again because plates don't stop moving. That sounds a lot to me like this old child's toy, where you turn this crank over and over and over again, and at some point you turn the crank too many times and up pops the clown and it scares you, just like the earthquakes scare you. So that makes me think, could we predict earthquakes by figuring out how fast nature is turning this crank? We have all these precise measurements from GPS that tell us how quickly the plates are moving and how much strain is accumulating. Couldn't we use that information to figure out when the clown's going to pop up, when the earthquake's going to happen? If that's all there is to earthquake prediction, it should be pretty easy. So here's our scientist, Alice Eastwood, saying, have you ever heard of the town of Parkfield, California? She's going to show us a situation where we have a lot of information about these earthquakes happening over and over and over again. There was an earthquake back in 1857. It destroyed some missions, a very large one near the town of Parkfield. An earthquake in 1901 when the town looked kind of like this. In 1934, you can see a windmill knocked over and some other buildings. And then in 1966, there was a modern-day road that got cut by this earthquake fault. And when there was a magnitude 6 earthquake, you can see that the striping on the road shifted a little bit to the right and kept on going. So this happened over and over and over again. And we can get a pretty good sense of this. So we can take a look here at how often earthquakes occur in Parkfield. Here are the different earthquakes. I didn't even show you all of them that we have. But between the first two earthquakes, 24 years. The second two, 20 years. The third two, 21 years. The next one just 12 years, but then after that, 33 years. So by the time you're all done with that, these average out to just about 22 years apart. And so 1966 plus 22 years, well, around the mid-1980s, people started thinking, you know what? That earthquake is coming. It should be coming any year now. They come every 22 years. So scientists spent millions of dollars installing equipment in there, trying to predict when the next earthquake would happen, trying to spot this pattern. This seems to be how quickly the plates are moving, and so the next earthquake should occur sometime between 1981 and 1995. Well, they did all that. They were all ready. They had cameras poised, watching the fault 24 hours a day, ready to record exactly what this earthquake looked like. But 1995 rolled around, and it still hadn't happened. 96, 97, 98, all the way up until eventually this earthquake did happen. You can't stop plate tectonics, but it didn't happen until 2004. Almost 10 years later than the latest estimate. So how well did the scientists do at predicting that earthquake? Admittedly, there are only 100 people in the town of Parkfield, but if they had told them in 1988 that they had to evacuate because there was an earthquake coming any day now, well, I bet those residents would have been pretty upset having lost 16 years of life in their home before the earthquake actually happened. So this is the challenge with prediction, is that you've got to get not only the place the earthquake's going to happen and the size that it's going to be, but you have to get the date right. Otherwise, a prediction isn't any good. So let's see, how easy is that to do? Well, our scientist again, Alice Eastwood, says, let's try and use the earthquake machine to try to predict earthquakes. And what is the earthquake machine, you ask? Well, take a look as a scientist from the U.S. Geological Survey leads us through what an earthquake machine looks like to him.